to a lecture series on igneous and metamorphic petrology. And since last 3-4 classes, what we have seen is the general introduction, followed by the classification of igneous rocks based on mineralogy, based on chemistry, and proposed by many scientists like leading scientists Sean, Harker, Tyrrell Stabler classification, and IUGS classification, and so on. After understanding that, what will happen to the magma when it started crystallizing? So the science started understanding with respect to many components, like if a magma is composed with a single composition, how it will form, how it will move. What is the examples of a single magma to be considered, single composition of magma to be considered. And similarly, if a magma composed of two different group of minerals, that is called a binary. If you have a two different composition, if the two different composition, how that it will settle, that is called binary. Sometimes 3, sometimes 4, 5, 6, and so on, 3 and more. So under these circumstances, so this discussion is about Unicompionent system, how a magma crystallizes with the Unicompionent system. That is this essay, crystallization of Unicompionent magma, how Unicompionent magma crystallize. Magma become igneous rocks by solidification without crystallization or with the loss of much of their volatile materials. So normally magma, what will happen, it becomes rocks when it is slowly getting settled to form as a form as a group of minerals. Solidification, it means when the temperature and pressure reduces, it starts crystallize. Sometimes it will not, if you are not allowing the time, what will happen, crystallization process will not be happen. Or with the loss of much of their volatile, it means gases which is coming out. And what will happen to the process of crystallization by Unicompionent system? The crystallization of magma by several factors. The magma crystallized, and there are many factors which affects the formation of or the crystallization process. Of which the first one is the temperature. Temperature is a major point in the magma, because magma is in liquid form. It is because of higher temperature. So all the minerals are in the diluted liquid form. So rate of cooling is the first thing to be considered for the formation of crystallization. So all these factors will affect the crystallization process in magma. The factors like temperature, the factors like viscosity in the magma, the composition of the magma, the concentration of volatiles. The composition, we have studied the composition from felsic to ultramafic, mafic, ultramafic, and all, that's from silica rich to silica less. So composition will play a major role. Concentration of gases which is present in the magma plays a major role. Again, it will control the process of crystallization. The amount of pressure, temperature and pressure goes together. If higher temperature and higher pressure, what will happen? If the temperature and pressure reduces slowly to the middle point, what will happen? And to the end point, the pressure depends upon the depth of cooling. The temperature depends upon the rate of cooling. So these two, the crystallization of magma is controlled by many factors, of which these 5 factors plays a major role: temperature, viscosity, composition, concentration of gases, and pressure. The crystallization can be best studied, as I told, that assume that a magma with a single composition, that is called Unicompionent. Assume that a magma with a double component. Assume that a magma with a triple component. With a single component, what will happen? With a double component, what will happen? With a triple component, and so on, much more. What will happen to a magma system is to be studied. Crystallization can be best studied by using a single magma system, double magma system, and a multi-magma system. So crystallization of Unicompionent magma, magma containing only one constituent, so it has only one composition. In crystallization of single pure mineral from a melt of its own composition. So crystallization starts from a single pure mineral, and you have your own understand that if it is a single composition, what will happen? The generation of there are two things. The temperature region in which the generation of crystal is slow. it means that is called a metastable region. If the temperature slowly goes down, if the pressure slowly goes down, it means you are allowing a crystal to form with all phases. So crystal will have a regular structure. With a slow cooling, with a that is called metastable. Which you see, it means the word carries a meaning. It is very stable to form a crystal. On the other hand, sudden cooling, if it is exposed to a lower temperature area, or if it is exposed to very lower pressure area, what will happen? Automatically, suddenly, the temperature will reduce from 100 to 0. If it, just pour a hot water into ice, what will happen to the hot water? You will know your water will immediately get vaporized, or sometimes it forms as a sudden cooling. So the other end is a rapid, that is called labile region. There are two things. Slow cooling, first one, metastable, leads to a coarse grained mineral formation. Rapid cooling leads to a glassy nature of mineral formation. So this is the best examples of understanding three forms curve. Like that if the temperature increases in x-axis and pressure increases in y-axis, what will happen to a mineral? If a mineral is said to be a solid, that is the best examples of water they have given. If pressure increases over ice, or if a temperature increases over ice, it forms as a liquid, or sometimes it moves from solid to vapor. So this is at the ideal place where you can find that to put together a liquid, solid and vapor at this junction. So example of a single component system for three phases, from ice, from liquid, from gases. Phases, you have three different phases of water. It is there in a single component system. This is the assumption that how hot H2O liquid magma plays a major role here. Three types of situations occurs here. It is a single phase coexisting as ice in water, phase coexisting ice in water. It is over here. T is the triple point at which it starts everything. So this is how your pressure temperature condition is there over solid, over liquid, over vapor. For a single component, a magma with a single composition, how it will form. So this is the example, best examples of hot water from a magma, how it will settle down with a temperature more than 100, more than 1000, more than less than 100, 0 degree temperature. You have three different formations, and then your H2O will form as a gas, H2O will form as a liquid, H2O will form as a solid. So with this Unicompionent as a discussion has come to an end. Thank you very much.